Good morning. So my name is Jeremy Njuguna, ID number 2247135545. And today I will be doing a presentation, an audio presentation on assignment 2 in the unit Real World Analytics, that is SIT 718. And the assignment was basically predicting white wine quality using aggregation functions. So on to the first slide. So the goal of this project was to predict the quality of white wine, and this was based on its chemical properties. So we were provided with a data set, CSV file, which is an Excel file, which has different wines with the 6 key features and a quality score. And the aim was to find the best mathematical model to combine these features into a quality prediction. So when I explored this data, I found that several variables were highly skewed. So for example, sugar and sulfur dioxide levels were right skewed, which means that most wines have low values with a few outliers. Quality scores were left skewed, with most wines receiving average scores. This told me that data transformation would be necessary before modeling. So to handle the skewness and to ensure that all variables are on a consistent scale, I was able to apply specific transformations. So I did use log transforms for sugar and sulfur dioxide, flipped the scale for acidity since it's negative for quality, and applied a power transform to the quality score. Finally, I normalized everything on a 0 to 1 scale. I tested 4 different aggregation functions to see which best modeled the relationship between our transformed variables and wine quality. And this included various types of weighted averages that handle inputs differently, as you can see on the slide. The fitting all models, so the OWA model, which is the ordered weight average, performed the best. So it achieved the highest Pearson correlation coefficient of 0.58, which indicates the strongest linear relationship between its predictions and the actual quality scores. So looking at the variable weights in our best model, volatile acidity emerged as the most important factor in predicting wine quality, which accounts for nearly 60% of the model's decision. Alcohol content was the second most important factor, while residual sugar had very little influence. So using our best OWA model, I predicted the quality score for a new wine sample with given chemical properties. The model predicted a quality score of 6, which falls within the normal range of wine quality scores and seems quite reasonable for these input values. So what makes a high quality wine? So according to our model, the ideal conditions for high quality wine are low volatile acidity, which is the most important factor, together with high alcohol content. So sulfur dioxide levels should be moderate, while sugar content appears to have little impact on quality ratings. So in conclusion, this model provides useful insights, but it has its limitations. So the aggregation functions are relatively simple and may not capture complex relationships between variables. So ethically, the data is properly anonymized, but we should remember that when quality is subjective and our model shouldn't be used to make definitive judgments about wine producers. So in conclusion, For my presentation, the OWA model proved most effective for predicting wine quality, with volatile acidity emerging as the most important factor. And the project demonstrated the importance of proper data transformation and showed that aggregation functions can provide reasonable predictions of wine quality based on chemical properties. Thank you, and that will be all for my presentation.